Download this code and get free GPT-4o from codegive.com, link in the description below. In Java, the runnable interface is a functional interface that represents a task that can be executed concurrently by a thread. The runnable interface contains a single method, run, which is intended to contain the code that constitutes the new thread's task. When it comes to stopping a thread that is running a runnable, there are a few approaches to consider. It's important to note that Java does not provide a direct method to stop a thread forcefully due to safety concerns. Instead, you should aim to signal the thread to stop gracefully. Tutorial on stopping a runnable in Java. #####1 Using a volatile boolean flag. One of the most common ways to stop a thread is to use a volatile boolean flag that indicates when the thread should stop executing. Here's a simple example. Explanation of the code. 1. Runnable implementation. The task class implements the runnable interface. It contains a running flag that is marked as volatile. This ensures that changes to running are visible to all threads. 2. Run method. Inside the run method, the thread continuously executes a loop while running is true. It simulates work by printing a message and sleeping for a second. 3. Stop method. The stop method sets running to false, signaling the thread to stop. 4. Main method. The main method starts the thread and allows it to run for 5 seconds. After that, it calls task.stop to stop the thread and waits for it to finish using join. ####2 Handling interruptions. Another approach to stopping a thread is using the interrupt method. This is particularly useful when the thread is waiting or sleeping, as it can respond to the interruption and terminate gracefully. Here's an updated version that demonstrates interrupt handling. ###conclusion. In this tutorial, we discussed how to stop a thread that is running a runnable in Java. We explored the use of a volatile boolean flag and the interrupt method to signal the thread to stop gracefully. When designing multi-threaded applications, it's critical to ensure threads can stop safely to avoid resource leaks or inconsistent states. Always ensure that shared resources are properly synchronized if accessed by multiple threads.